Hello everyone. So today's topic is derive the expression for conduction current and displacement current density. So first we go for with that conduction current. So the conduction current I is flowing through a conductor whose resistance R when potential V is applied across the conductor. So IC equal to V by R, the relation between the Ohm's law. IC equal to V by R. IC is the conduction current. So we know that R equal to rho L by A, that is L is the length of the conductor, where A is the cross section of the conductor, then rho is the resistivity of the particular material. So in the another form, R equal to 1 by sigma into A, the sigma is represented as a conductivity of the particular material. Sigma is also we represent as an 1 by rho. If the E, that is the electric field existing in the conductor, V equal to E into L. So therefore the conduction current we have to written as IC equal to V by R. So V equal to E into L. So you have substitute with that value E into L divided by L. So it represents into sigma into A. So therefore the conduction current IC equal to E into sigma into A. Then the conduction current density. So current density is JC. We have to represent as conduction current density. So the total current enclosed by the particular surface area. So JC equal to IC by A, which will be equal to sigma into E. So IC divided by A, we have to substitute with that E into sigma into A divided by A. So we have to represent as a sigma into E. So therefore the conduction current density JC equal to sigma into E. So this is the conduction current density. So next we go for with the displacement current. So the displacement current we have to represent in the ID. So the displacement current ID is flowing through a capacitor when AC voltage is applied across the capacitor. So ID equal to dq by dt. So q equal to C into V. So we can written as equation C into dV by dt. For the parallel plate capacitor, C equal to epsilon into A by D, where epsilon is the permittivity, where A is the area of the conductor, D is the distance between two parallel plates. So the displacement current ID equal to epsilon into A by D into dV by dt. We have to substitute with that equation epsilon into A divided by D into V by D equal to E, so dE by dt. So the displacement current ID equal to A into dou D by dou T, where D we can written as D equal to epsilon into E. So therefore the displacement current density JD equal to the total displacement current to the particular area. So displacement current density JD equal to ID by A. So JD equal to dou D by dou T. So these are the conduction current density and displacement current density. We have to use that particular formula for deriving this equation for conduction current. So conduction current JC we can written as sigma into E, whereas as displacement current JD equal to displacement current dou D by dou T. By using this formula we can derive some problems based on that conduction current and displacement current for the given values. So thank you. So hello everyone. So next we have discussed with that comparison between the circuit theory and field theory. So in the case of circuit theory, this analysis originated by its own, whereas a field theory, so it's evolved from the transmission theory. So in the case of circuit theory, applicable only for the portion of RF range. Then in case of field theory, so it represents beyond the RF range. The dependent and independent parameter for current and voltage are directly obtained for the given circuits. So in case of field theory, so not directly through an E and H. In case of circuit theory, the parameters of the mediums are not involved in the circuit theory. So in field theory, the parameters of the mediums are involved. So in the circuit theory, we are using with that Laplace transform is employed to solve this equation, where in the case of field theory, using that Maxwell equations is employed for deriving that the equations. In the circuit theory, we are concentrating only for Z, Y and H parameters are used, whereas a field theory we are using only in the S parameters. In the case of circuit theory, low power is involved, whereas a field theory, so relatively high power is involved. So in the case of circuit theory, simple to understand that concept. Where in the case of field theory, so it is an analysis part that is needs to visualization ability is need for the understanding the field theory concept. So the last point, the two-dimensional analysis representation is to be carried out in the circuit theory analysis, where in the case of field theory we have to use with the three-dimensional analysis. So in the circuit theory, frequency is the reference variable, whereas in the field theory, wavelength is a reference variable. So in case of circuit theory, we are using method components as in lumped parameters components. In the case of field theory, we are using only with that distributed components are involved. So these are the some parameters we have to consider for the differentiate between the circuit theory and field theory. Thank you.